Hey guys, I'm Kevin from Tarana Wireless. We make wireless equipment that delivers internet to really hard to reach locations. Two of these systems form a wireless link. You take one of the systems and you put it at an internet source, maybe on top of a tower, on top of a building, and then you take the other one, you put it at a hard to reach destination, something like a remote site for the energy field. Inside of our equipment are a bunch of antennas and signal processing that provide us multiple product differentiators. In particular, in the oil and gas industry, you guys will take advantage of our non-line of sight connectivity and our auto antenna alignment. Wireless equipment traditionally is installed at a source and destination, but you need line of sight. So they're always installed at these really tall towers, like what you see when you drive down the freeway. Once you install these equipments, you need these RF engineers to align the equipment, the microwave equipment, to establish and maintain connectivity. But with our gear, because of all the antennas and the antenna array inside, it can be installed by a tower climber called a rigger, so someone really cheap and inexpensive, so you don't need these RF engineers. The rigger will climb up, install the gear at the source, then go to the destination, and the link will automatically find itself. And an antenna array is just like radar where you can scan, and the system's always trying to maximize the signal and maximize the data rate. So the other product differentiator is non-line of sight operation. As I mentioned, the destination for the traditional microwave gear has to be on top of a tower, but on ours, at these remote sites, a tower may not exist. So a tower can be maybe only like some makeshift pole, or it can be some just low to the ground site. And that means as you're low to the ground, you can't see the source. So there's many, like maybe buildings or in the energy space, hills, canyons, or valleys between the source and destination, which makes connectivity really difficult. So what are we trying to do? In particular, or your home internet, you're being charged 60 or 70 bucks a month, but in the oil and gas space, you're being charged for telecom connectivity, $20,000 a month. So we're trying to reduce that by 75% and increase the data rates by 50 times. So why is it $20,000 a month? And a typical oil and gas facility will have multiple VSATs, satellite modems. They'll have multiple LTE modems. And the VSATs are really expensive. So if you want, they're hundreds of dollars per month, or per day, per megabit per second. And you're going to have multiple. And if you want higher data rates, you're going to have to pay more. You're also going to have multiple LTE modems that are going to monitor sensor data, and that's going to be really low data rate because you're at this remote site. And just like as if you're far off in some park, some national park, you're going to get low data rates because you're at the cell edge. Same thing for oil and gas. So we've done tests and trials and events and deployments with companies like Vodafone, delivering connectivity to ships. Backhauling 3G sites, a ship will drive up and down the shore, and we'll always backhaul that connectivity just to show that we support ship-to-ship communication, ship-to-shore communication. We've deployed with, or we've delivered connectivity to ferries to support hotspots. So if you take the ferry, you'll always have fast internet. And then the remote sites, in particular, we've worked with Chevron, delivering connectivity like 40 miles near line of sight or non-line of sight connectivity. So we're looking forward to working with more energy companies, whether they're strategics or if they're venture groups. And we'd like to talk to you. Thank you.